Hello, my name is Kenny. I'm an incoming freshman at Stony Brook University. So my intensive project, the knee brace sensor, what I've done here in this milestone was I sewed together like all the main components, so the bend sensor, the Arduino, and this perf board. And basically, what I've worked on besides that is also the accelerometer. I've both configured it through calibration and also converted it from 6-bit data into comprehensible meters per second, which is the units per acceleration. So I'd say like besides like the sewing was just like trying to find a place that was comfortable for like all the, because the Arduino's a bit bulky, so I just decided to put it next to the bend sensor, which the bend sensor would bend along the knee. And so like for the accelerometer, basically like the first part was calibrating, which wasn't too hard. It just really required finding code online and just holding it still for a few seconds and having it find the correct orientation for X, Y, and Z. But the trickier part was actually trying to convert the data from, because it was giving out hex numbers, and changing that to decimal numbers, and then finding a constant that would basically make it so that the accelerations are all set to their normal orientations. So for the hex, changing hex to decimal, it took basically finding a code online, just doing a bit of research and then finding code online that like had a library called Wire that would basically do the changes for you. And then as for the conversion from decimal to, from decimal to acceleration, basically I just had to play around with like trial and error, trying to find like the right number constant that can be multiplied to the raw data that could have a 0 acceleration in the x-axis, so from like left to right, like this way, and then z-axis also has to have 0 acceleration, so like backwards and forwards. But the tricky part was having the y-axis have 9.8 meters per second because that's up and down, which is affected by gravity. So I mean, just playing around with the numbers, I eventually got accurate data. As you can see, it's kind of running here. If I hold it straight down, it's right about correct. Yeah. There's going to be a bit of error because I'm shaking a little too. So yeah, that's basically it for this milestone.